Casey Smith is a security analyst from Denver. 303 represent. Thought there'd be a few. Here to talk about application whitelisting evasion.
Great. Can everybody hear me okay? All right. No? Okay. So my name is Casey Smith. You can connect with me on Twitter at @subT. We're going to explore simple application whitelisting evasion techniques. He already mentioned I'm a security analyst for First Bank in Colorado. My role primarily includes internal security testing as well as incident response. So we're a small enough shop that we get to actually see both sides of the coin. So the reason I titled this talk Simple, No Exploitation Necessary. So we're going to take a look really from a defensive perspective, what might you see an adversary try to evade your whitelisting tools? So we're going to use tools like Notepad, C# compiler, some PowerShell, and we're going to be able to evade many of the whitelisting applications that are out there. Just to level set, so everybody's on the same page. Application whitelisting is, the idea here is that anything that's unknown or unapproved does not execute in your environment. So what we're going to be able to do here is approve a file by the file hash, potentially by a trusted directory, or by a publisher or the signature associated with the file. That becomes important when we look at different tactics that we're going to use to evade those. Some of the research that we've uncovered is the ability to run a binary even if it's been banned at the file hash level. So I think you'll find that very interesting. 3 levels of evasion that we're going to look at. We're going to start very basic, script files. So VB script, batch files, PowerShell scripts. Then we'll move into .NET or managed code execution. And then lastly, we'll look at native execution. So a rogue binary that you create, execute that on a workstation. So scripts, don't be interesting. A lot of these tools are going to use for interesting file extensions, and so we have things like .bat files, .vbs, .ps1. In a Windows environment, if you're going to run your content from a script, don't use those known extensions. And so that's a very common tactic that we'll see. You can actually execute the content of a script from a text file or an Excel file or whatever extension you want. So here's 3 techniques that you can use, very simple to evade somebody that might be trying to block a batch file. So you just simply redirect the content of a script into the command processor and it will run fine. There's a number of ways to chain commands together in Windows to still achieve the action on objective. So not that great. You're not going to get that much with the batch file, honestly, maybe some automation, but you'll see an example of how this works. With VB, again, same thing. We're just going to pull the content from a text file as opposed to a VBS file. And PowerShell, I'm going to spend a fair amount of time on this at the end, but you can simply call get content, whatever the file type is, and then pipe that to IEX, which is invoke the expression. So wherever that content comes from, we want to execute that, whether we've downloaded it or whether it's a file we've written to disk. Let's take a look at that. So here you can see we have a simple batch file. We try and execute this in our environment. All it does is list the shares. What I've outlined in red there is the application whitelisting, giving us the famous access is denied. We're not able to execute that script. However, you can see about the 3rd line down there, we just run command, pipe the text file content in, and it enumerates shares just fine. Like I said, not all that exciting, but as we evolve the different techniques, I wanted you to see the simple to the more complex techniques that we can use. All right, .NET execution. So manage code. This is a framework that ships with the operating system very often. It's on servers, workstations, kiosks, other devices. Our team uses the term sponsors, which are trusted things that execute things. And so we have a number of sponsors that we've identified. I'm going to talk about 4 here today. I would love feedback on people that may find other sponsoring executables in environments as well. So I'm interested in feedback on this in the research. You know, a word from our sponsors, if you will. Primarily, an attacker is going to be more interested in what an application can be made to do and operates on the principle that any action not specifically denied is going to be allowed. So the idea here is some of these sponsor tools, I don't really care necessarily what it was intended to do. My goal is to run a rogue binary, so I'm going to misuse or misappropriate that application to accomplish the action. So that's what we're going for here. So you'll see the very first tool here is called install-util.exe. How many have heard of this tool before? Okay, it's on every Windows machine that has the .NET framework. This tool will actually hatch a payload or hatch a binary for you It's a trusted, signed binary that exists and is very often pre-approved in your whitelisting tools. I've posted a sample on my GitHub page there. I'll be publishing the slides of this talk there as well, so you, just for reference, I put the link there. The other interesting capability of install-util.exe is we can actually confuse somebody that's trying to do dynamic or static analysis. We can run the binary one way and present one behavior, and then when we invoke that exact same binary with install-util, it presents a completely different behavior in the environment. So this is definitely something that if you're running a whitelisting defense, you probably want to consider banning this particular file. Here's how it works. So install-util.exe uses a technology called reflection, and it loads the assembly into its own process space. So what happens is, think of it like ingesting the binary and then running inside of install-util.exe. So if somebody's looking at their logs, they're going to see that install-util ran. They're not going to see the rogue binary that you created. So you just write two functions in your application. I'll show you an example of this code in a moment. But you have a main function. That's the default behavior when you type in the command and execute it. And then there's the install method that install-util.exe looks for, and that's what it runs when you invoke it using this tool. So think of install-util.exe as a custom application launcher that's available on every Windows workstation in your environment. So definitely be watching out for this tool. Here's a demonstration. So our team developed a custom app. We call it Malwaria. And basically what it is, it's a .NET executable that runs a interpreter shell, or shellcode essentially. Shellcode, we can put a DLL or an EXE in there. I'll talk about that a little bit later. But you see, I tried run Malwaria. I type it in at the command prompt, and I get the whitelisting tool says access is denied. You're not going to be able to run that in this environment. However, if I simply invoke that with install-util.exe and a couple of special flags there, we enumerate the type of resources in the file, and then we connect via a reverse HTTP shell back to our server. That's what you see over on the right. So the whitelisting did not stop the execution event in this situation, and that's really one of the important things about install-util.exe. It's there by default. I don't know if this is going to show up well on the slide deck, but there's a 22-line script I created for you to test. Those of you who have whitelisting tools, or those who are doing offensive testing, and you have a client that uses these technologies, you probably want to run this test in their environment. We have a simple main function, and then we have the decorated class, if you will, called sample, that has inside of it a function called uninstall, and that can be invoked via install-util.exe. How does the proof of concept work? Well, you simply compile it. Every Windows machine has a native .NET compiler. For the most part, you'll find this. You simply invoke csc.exe wherever the path is, create your arbitrary binary on disk, and then you invoke it with install-util. There's a couple of flags you're going to need to use to get this to work. It's going to create a log file, and you may or may not want to log to the console, and then /u means we're just going to call the uninstall function. Install is transactional and really overkill, so we might as well just use the uninstall piece. We're not uninstalling anything. We're just trying to run a binary in a restricted environment. The root here is the way in which assemblies are loaded. So .NET uses the concept of a managed code or assembly instead of an EXE, or it is an EXE, but the assembly.load method can be used to call a file from a byte array, so in memory, a local file on disk, or even a URL. There's even, on the app domain class, you can call execute assembly. So it's not just install-util.exe we're talking about. We're talking about any .NET application that you could influence the path of the assembly could be vulnerable to this type of execution in a whitelisted environment. So again, I'm curious to see if others can find techniques like this that we've discovered in our research. How can an execution event be missed? Isn't that the point of a whitelisting tool? At the root of this is the .NET assembly gets loaded with a read permission. And the read permission is to enumerate the methods and properties associated with that binary. Later, permissions change to execute. And this is where your whitelisting software can miss this. And it's an important architectural problem that I'll give more details in some of the proceedings documentation, but I want to give a quick thanks to Bit9 We worked very closely on this once we uncovered this. Matt Larson and Chris Lord, we really dug in and said, why am I able to execute this using this particular piece of software? So it's, again, not just install util, it's anything that you can influence the assembly.load method. Another reference here for AppLocker, the same technique can be used to bypass AppLocker. Those of you who are using AppLocker, I highly recommend you read the TechNet article that I've referenced here. It gives guidance on what the security considerations are, so essentially what AppLocker can and cannot do. Again, Microsoft provided this link to me to share with you guys, and so I wanted to make sure that I put that on display here. Are there other sponsors? So there's install-util.exe, there's assembly.load. Yes, there's actually quite a few. I'm going to talk about 4 in total today, but essentially we've got IE-exec. So this was about a year ago. I was sitting in training class for the Bit9 software, and I started thinking, this is going to change everything, the way we operate as a pen testing group. And so Rob Fuller was kind enough to post this on his blog. The IE-exec utility is documented here on a Room 362. I'll be the first to admit it's not a great tool, but it does work, and it proved our theory. So you can actually invoke from a URL a binary that's hosted on another server and get that to execute in a whitelisting environment. So this one was our first sponsor, if you will. Here's another one, Click Once. How many of you are familiar with Click Once technology? Anybody? A couple? Okay. So this is browser-based software delivery. And what it allows you to do in a whitelisted environment is gain that initial foothold. Because one of the things that's tricky is, how do I run my file if I can't get access to the machine in the first place? Well, being browser-based delivery, we simply send a link into the user and let them make a trust decision. All right, so they're going to get a pop-up that says, would you like to run or not run this file? So there's obviously some risk associated with that. The application typically has a .application extension. Those of you defending would probably want to look for that in your logs or block those MIME types in your proxies. Again, you may consider, if you're doing offensive testing, try this instead of the Java applet payload. Accomplishes the same thing. We simply embed our shellcode into a Click Once application. The user makes the trust decision to run our app, and we've got a shell on the box. You can also invoke this with df-svc or df-shim.dll. And you can see here, this is an example. This is a known pattern, so it's not going to be something the user has never seen. This is the Chrome installer. And so Chrome installer, if you see on the right there, is being actually executed by df-svc.exe. And again, that's a trusted signed binary, likely going to get us an execution path. Here's another one, presentation host.exe. So this is actually used for XML browser applications, so you can actually develop a GUI that runs inside of the browser, if you will, using the .NET framework, the tic-tac-toe, other applications, whatever you want. But you can actually invoke the file via presentation host, and you can either call a local file or a URL. Again, I'll be publishing some of the MIME types to watch out for these applications if you're interested in blocking these, but you can run the executable because it's processed by presentation host.exe. It's not the rogue binary that's executing. Does that make sense? Does everybody see how that's happening? Okay. Okay, so we looked at scripts. We looked at .NET or managed code execution. Lastly, we want to take a look at native execution. So take any arbitrary binary, Mimikatz, for example. We want to be able to run Mimikatz on a machine that's in a completely locked down state. So how do we do that? A couple different ways. One is a tool I'll be publishing later called Malware. Again, it's a .NET tool that allows you to run a native binary inside of a .NET space. So if you can find a .NET sponsor, then we can probably be able to execute our binary. We'll add ability to encrypt native payloads and unpack from memory. These are not things that are new. Adversaries use these all the time, so we're going to be able to demonstrate adversarial tactics using a tool like this. Now, PowerShell, probably the best sponsor out there. So in a whitelisted environment, PowerShell gives us incredible access to the .NET framework. And so this is not a tool that we developed. This is a tool that was developed by the PowerSploit team. How many of you are familiar with PowerSploit? A number of you? Okay. It's an excellent tool, amazing tool. I could talk about it quite a bit more, but I wanted to call attention to one script in particular. And that is invoke reflective PE injection. Has anybody heard of this tool? Okay. What this does is allows you to take a native image, embed it into a PowerShell script, and execute it right inside of the process. So there's actually invoke Mimikatz, there's invoke reflective PE injection. This becomes problematic because we trust PowerShell to run. We can even stage the execution so it's downloaded from a URL and then runs in stages on the workstation or server. So we decided to build a custom example of this. There was a local privilege escalation exploit that came out last year, and as a demonstration to our internal teams, we took that exploit and embedded it in PowerShell and ran it, and there was nothing that tripped in the whitelist. How did this work? Again, essentially you take the exploit, compile it, base64 encode that. You can either embed it right into the script, or you can host it on a server, and then you simply run from PowerShell, invoke reflective PE injection, and whatever you've embedded there will execute on the box. Here's an example. You'll notice one thing that's missing on this slide that was present on the other two slides or demos. There's no access denied here. So I ran this script in a PowerShell box. I said, who am I? Well, I'm just a research. I then, on the third line down, call IEX to invoke the expression. We're going to download the file. The verbose output is just a parameter you can associate with the script. And if you notice at the bottom of the script here, I'm in the authority system, all contained in a whitelisting environment. So this is something that you will definitely want to watch out for this script or some of the strings. There's a known pattern for a base64 encoded binary, but if it's encrypted, it becomes much more difficult to detect. What about other tactics, methods? So we've looked at using scripts, .NET, native code execution. There's a concept of living off the land that was presented at DerbyCon 2013, and I put that in here for reference because what happens if your adversary stops using rogue binaries? What if they're not dropping malware? What if they're using what's natively installed on the operating system, using only what's consistent with the way the admins use the tools? So instead of using new unapproved, which gets denied, we start using pre-existing trusted. So the classic examples here would be like set.hc, where you hit the shift key 5 times and it pops a shell before you log in. There's some great examples documented in this YouTube clip. Here's one that we've used. How many of you knew that when an Outlook, you create an Outlook rule, you can actually run a script? Anybody doing that? Okay. So this is kind of fun. So you send a specially crafted email into the target, and it will execute PowerShell or whatever script you want and return those results back to an adversary. There's not a lot of whitelisting tools today that are monitoring macros or scripts that are running inside of the Outlook process. So again, we're seeing a shift where adversaries are using some of these tactics to evade the whitelists. Certificate forgery. Again, this was one of my favorites. We use this to test some of the newer analysts all the time. So I sign a code that looks like it's from a trusted vendor. It's just self-signed. So it's self-reported metadata on the file, who the publisher is, who the company is. It cryptographically doesn't check out, but it may just get past somebody that's looking at a file only based on the publisher. Oh, that's vendor A? We should probably approve that. Add a little bit of urgency to the file, we may get past. So there's nothing really sophisticated here. We're just simply using free tools to sign our binaries to try and get it past someone making a trust decision. I'm almost out of time here, so I want to just be brief, but driver and OS level attacks. So nearly all whitelists are implemented as a kernel mini-filter driver. So you have the potential for exploitation that can stop or disable these services in an attack. So this is an area we're exploring, but hopefully you've seen some of these tactics I presented. The adversary doesn't necessarily need to go here. If they've got .NET Framework or access to PowerShell, they can likely circumvent some of these controls. All right, in conclusion then, resistance evolves. So this is a picture of the Anopheles mosquito. I first met this mosquito in Uganda in 2002. I contracted malaria twice. This thing is evolving, right? So this mosquito changes its tactics. It's actually developing DEET resistance, anti-malarial medication resistance. So we see this in the natural world, the evolution of some of these type of species. It's only natural that we're going to see as we deploy a whitelisting technology that adversaries are going to shift tactics and evolve to evade those. I wanted to leave at least a minute or two for questions. So again, thank you for your time. There's a question here. Yes. Well, I don't have a URL for the slides. I'll post them on my GitHub. So which URL were you referring to? Sorry. Oh, yeah, sir. Okay, so that one was a proof of concept. Sorry. There you go. Okay. I'm getting a stop here, so I think I need to stop. But again, I'm available for the conference. I'd love to have more conversations. Thank you so much for your time today.